Hello and welcome to the NRP 62 studio. Smart materials are on everyone's lips. But what does it actually mean? We will ask the president of the National Research Program, Smart Materials. Professor Schlappbach, what are smart materials?
All materials have properties and functions. Smart materials adapt their functional properties upon exchanging external parameters in order to maintain their function. They are susceptible to changes in the physical, chemical and biological environment, so they are able to act upon specific external stimuli. Example is aircrafts, birds and flying insects. They adapt the shape of their wings to the flying speed. Let's have a look at the force between this strong permanent magnet and this little red cylinder from my pocket. Apparently, there is no attractive force. Now I cool the cylinder by some centigrades and wow, it is strongly attracted by the magnet. And the effect is reversible. Upon exposure of the red cylinder to the heat of that halogen lamp, the attractive force disappears again. You know, innovation is the key to a novel technology.
An innovation process starts when researchers ask fundamental questions such as, could it be possible to coat implants with smart carriers so that they can deliver their antibacterial effect directly, but only when and where an inflammation is detected? When I drive my car, I always wonder if driving could be more environmentally friendly by means of an intelligent catalyst. Researchers choose different ways to pursue their visions. One way is to combine known effects with known technology in novel fashion. Professor Michael de Wild from the University of Applied Sciences of Northwestern Switzerland took powders of shaped memory metal and built responsive implants by 3D stereolithography, which involves a laser that melts the powders into precise structures. His colleagues from the University Hospital of Basel now examine these structures for their ability as smart implants. Other researchers embarked on more unusual journeys of discovery. EPFL Professor Damjanovic looked deeper into the different contributions to the piezoelectric effect. He found new ways to piezoelectric properties and quite unexpectedly uncovered a symmetry breaking process, changing the way one looks at lead-free piezoelectrics. These examples show how interesting the last 5 years have been. An array of exciting new insights is the result of NRP 62 research. In an interdisciplinary approach, Till Sachser, Bert Müller and Andreas Zumbö from the Universities of Geneva, Basel and Freiburg realized a specific coronary vasodilator with nanocontainers. The vasodilator releases its cargo of blood vessel opening drugs only at locations where atherosclerotic constriction is present. This intelligent system will effectively fight atherosclerosis, which is today's leading cause of death. Professor Wolfgang Meyer and his team at the University of Basel immobilized block copolymer membranes to solid surfaces and nanoreactors. This approach provided new types of responsive biosensor systems with enhanced stability and active surfaces that allow the local production of bioactive compounds. In addition to the application-oriented technologies, the program also boasts some groundbreaking basic science results. The project Functional Organic and Organometallic Materials for Molecular Electronic Applications serves as an example. Professor Meyer explains.
These findings open the door to molecular electronics, where the structure sizes differ largely from today's electronics. Lines and structures on actual chips are 1,000 times smaller than the diameter of a human hair. Molecular devices are even about 1 million times smaller, but they still have the structural diversity required to design their electronic function. This opens not only new horizons in computing with smaller and faster functional units, but also might reduce the costs of future integrated circuits.
Professor Heinz Berke from the University of Zurich explored the correlation between molecular structure and electronic properties of molybdenum complexes. These novel functional smart molecules can be electrically addressed by 2 gold electrodes without the need of an additional gate electrode. Dr. Heike Riel from IBM Zurich, one of the industry partners of NRP62, developed the molybdenum systems in collaboration with Professor Berke. Dr. Riel, what could you tell us about these novel molecules?
In the first phase of the project, we have demonstrated conductance switching in single molecule measurements. This switching originates from the intrinsic molecular functionality, in this case, the redox functionality of the transitional metal complexes. The molecules were contacted by 2 gold electrodes, and there is no need for a gate to make them switch. This switching is reversible, reproducible, and controllable, and thus very appealing for future memory applications. This new class of redox-active organometallic molecules is very promising for future molecular electronics applications.
Dr. Riel, we thank you very much for the statement. Here are 2 more comments from industry.
Materials with novel properties and intelligent combinations thereof are key to innovation for the Swiss industry, including the chemical industry. The National Research Program 62 has opened many new fields in smart materials which are of high interest to me and my actual work, such as materials for electronic and optical applications, bio-inspired mechanically responsive polymer nanocomposite, smart vesicles, and many more. The project results have been exposed to industry in several technology aperçus, where I learned a lot about these new materials and its properties. For me, it also presented an excellent occasion to meet all experts from face to face and have intensive, good discussions.
Thanks to the National Research Program on Smart Materials, we had the unique opportunity to make contact with projects which are very exciting for industry. Professor Wolf and his team of researchers from the University Hospital Zurich and ENPA had the vision to build a non-invasive system that utilizes smart materials to measure the blood sugar concentration. This system analyzes the fluid that passes through the skin. Now we are establishing a joint project supported by the Innovation Promotion Agency, CTI.
The NRP62 is a notable and unique cooperative program between the Swiss National Science Foundation and the Commission for Technology and Innovation, CTI. Professor Martina Hirayama is a member of the steering committee of NRP62 and vice president of the CTI. Professor Hirayama, are you satisfied with the approach?
There was no expectation that NRP62 would produce marketable products. However, the intense research and development phase formed the basis to create 7 CTI projects. These projects are targeting highly promising and innovative products in close collaborations with new startups and industrial partners. In this sense, NRP62 has become a reference model for a successful collaboration between SNSF and CTI.
Professor Martina Hirayama is also convinced that NRP62 had a high impact in terms of education.
NRP62 addressed researchers from natural and engineering sciences as well as from life sciences. Students from physics, chemistry, material science, biology, pharmaceutics, medicine, environmental science and engineering, mechanical engineering, and electrical engineering have learned on the job how important interdisciplinary approaches are to science and technology. The enthusiasm of our students at the universities and the universities of applied sciences is also worth mentioning. Here are some of the students' statements.
I had a great time doing my PhD and was really grateful to have had the opportunity to conduct my research within such a supportive framework. I profited from the joint interdisciplinary training for young scientists in material sciences at the University of Lugano and in Merton. I was also delighted when I found out I had won the NRP62 PhD prize, which funded a 1-year postdoc at the Stevens Group, Imperial College, London.
My best moment was when we deciphered the self-assembly process of our vesicles. This was during the microscopy session when an unfinished compound suddenly appeared on the screen. This revealed to us the unknown intermediate step. This realization became the baseline in my thesis and was a leap forward in our project.
Looking back at the program, Professor Louis Schlappbach, president of the steering committee, is very enthusiastic. The expectations were high when the program started 5 years ago. Professor Schlappbach, how do you rate the program's success?
The National Research Programme 62 pursued a twofold goal: to encourage scientific research in an emergent field for Switzerland, including the transfer of results to innovation, and to promote the education and career of young scientists needed in the field. We encourage projects with high potential for industrial application, as well as exploratory projects. Knowledge in solid-state science and high-level understanding of the physical, chemical or biological phenomena has always been a prerequisite for our research. I was surprised to see some visionary projects unexpectedly developing into real shooting stars. Often I thought, that project is never going to make it, and all of a sudden it achieved its far outreaching objectives and attracted industrial interest. On the other hand, some promising projects never met our high expectations. We are particularly proud of the successful transfer of scientific results elaborated in the first phase, use-inspired work, into research and development projects with focus on CTI-promoted innovation, startup formation and interdisciplinary collaboration. That cooperation between National Science Foundation and CTI made the program stronger. And in addition, higher education is a noble task. We are proud to have created 20 PhDs.
Professor Schlappbach, thank you.
You are welcome.
Dear audience, we hope that this video has arisen your interest in the approach, the scientific results, and the outreach of National Research Programme NRP 62 Smart Materials. We thank you very much for your attention. We will keep you informed. Goodbye.